In lesson 5.01, we will be looking at parallel lines and transversals. So recall that we have angle relationships that we've already discussed, such as vertical angles, complementary angles, supplementary angles, and of course the linear pairs. And you can see a few diagrams and examples of what those may in fact look like. Remember, with complementary, the sum is equal to 90 of both of the angles, and the supplementary angle pair has a sum of 180 degrees. A transversal is a line that intersects two or more lines in a plane. So in this diagram that we have on the lower right, we have lines intersecting each other here. In this case, the line T is the transversal. It is intersecting the two lines M and N, and it creates 8 different angles when it does this. Now, M and N, when we say they never intersect, that's the same thing as saying that M is going to be parallel to N. So for future diagrams that use this exact diagram, we're going to make that assertion that they are parallel lines in this case. Transversals can also intersect non-parallel lines as well. M and N are not transversals of each other. So the first type of angle pair that we're going to address is the corresponding angle pair. And these are angles that lie in the same position or match up when a transversal intersects two lines. Now I've created two different groups here, groups of 4 that is, and so you can see the group that's highlighted in yellow, 1, 2, 3, 4, and then 5, 6, 7, 8. They're grouped respective to the line that they're on, right? So one group is around or it belongs to line M, and then the other one belongs to or is grouped around line N. And so the relationship that I want you to remember as well is remember that we are stating that M is parallel to N. So if M is parallel to N in this particular case, then we can say that the corresponding angles are congruent to each other. So let's take a look at what those angle pairs are going to be. So the corresponding angles are angles that match up with each other. So for example, from the first group that lies on the line M, we have 1, 2, 3, 4. 1 and 5 are grouped together, or are rather corresponding, because they are in the same location respective to their group. So you can think of it as the upper left of the quadrant of angles that we have. So 1 is in the upper left, 5 is in the upper left. They're corresponding. 2 and 6, 3 and 7, and 4 and 8. So those are going to be congruent, but remember they're only going to be congruent as long as we also recognize that the two lines here and here are going to be parallel, right? So if they're parallel and they're cut by a transversal, then those matching angles, those corresponding angles, are congruent to each other. We also have the alternate interior angle pair as well. So with the alternate interior angles, they're angles that are in between the two lines that are not the transversal. So the space that I'm referring to, which I'll highlight in yellow here, I'm referring to this right here. This is the interior of the two lines that you can see. That's what I'm referring to. And that means that they're in between those lines cut by that transversal. They are interior, but they're also alternate. They're alternate because they're on diagonal opposite sides. So when we talk about the word alternate, we're actually referring to this description right here. That's what that means. So you've got 3 and 6, and you've got 4 and 5. And likewise, assuming that M and M are parallel, or knowing that they're parallel, means that the alternate interior angles are congruent to each other. Of course, that also allows us to look at the alternate exterior angles, for the exact same reason as I mentioned before. Now the outside in this case, which I'm still going to highlight with yellow, is out here, for example, that's the exterior, and this is the exterior of those two lines. Okay, that's what that means. And then of course, alternate being on the diagonally opposite from each other as reference. So we've got 1 and 8 and 2 and 7. And as before, as I've said, if M and N are parallel, then we know that those type of angles are congruent to each other as well. So there's lots of color coding here that can help you illustrate which angles are matching with which and which are congruent. So these diagrams are in some ways repetitive. The last angle pair that we'll look at is the same side interior angles. Sometimes these can also be referred to as consecutive interior angles. So if you ever see that adjective being used, it means the same thing. And they're angles that lie between the two lines, right? So we're interior, it's actually in the name. So interior means we're on the inside here. However, unlike alternate interior, 3 and 5 and 4 and 6 lie on the same exact side as the transversal. So 3 and 5 and 4 and 6 are supplementary. If we know that M and N are parallel, this is the unique relationship that, unlike all the others that are congruent, these are supplementary. All right, so their sum is equal to 180 degrees. So let's take a look at our first example here. We're going to identify the type of angle pair that is created. So when we look at our first example is going to be angle 1 and angle 5. Those are going to be in the same position respective to their group, so that means that these are going to be corresponding angles. Those are corresponding angles. I'm just going to write corresponding. 2 and 8 are the next pair of angles, so we have 2 and we have 8. You can see that they belong to the transversal D, right there, and they're on diagonally opposite sides, and they are on the outside or exterior of the two lines A and B. So that means that these are alternate exterior angles. Alternate exterior angles. Next we have 1 and 9. So 1, again, we've already kind of illustrated 1 before, but I'll do it again. 1 is right here, but 9 is right here. So notice how this lies between the lines, right? So they're on the interior, so they're an interior angle pair, and they're diagonally opposite each other. So that is going to be alternate interior angles instead of alternate exterior. They're also not same side interior because they're not on the same side of the transversal. And then of course you have 2 and 10. So when we look at 2 and 10, 2 and 10 is interesting because they might appear to be in the same position, but actually there's no relationship. And the reason why there's no relationship is because of that line D. Okay, so just looking at the screen, if you look at angles 2 and 3 combined, whatever that total angle is, that corresponds with angle 10. But by itself, 2 does not correspond with angle 10. So while you might think it's corresponding, there's actually no relationship between 10 and 2 at this time. So we can't define or identify it as any of those. And the reason that happens is because of this transversal D cutting this angle here into 2 other angles, which is exactly what it's doing. So here's another problem where we just want to identify the lines that A intersects, for example, or B, C, and D intersect. So when we look at this, we want to first define the lines that intersect A. And so A is this line right here, as we can see. And we see it intersects 3 different lines, right? We can see that it intersects line B, C, and D. It actually intersects all 3. Now we're only containing ourselves within the orange box. We know that lines are continuous and they go on forever, but if we just look at what's inside of the orange box, A is only intersecting those 3. And then of course we have B. What does line B intersect? So line B intersects only line A in the diagram. Then we have line C. Line C intersects A and D. And line D intersects, and I should probably color code these, right? This was line C, this was line B, and of course, as I mentioned, line D. Line D intersects A and C. So it's important that you are able to identify the lines which are being intersected as well, because that can help you determine what the transversal is, what it's not, and what groups of angles to compare to each other when you're trying to classify them. Let's take a look at a proof of angle congruence. Okay, so here we're proving that we have angle 1 is congruent to angle 6. So the end goal is to prove that, and we want to go ahead and label, 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 okay? You want to label, label, label. Label as much as you possibly can on your diagram, right? So we know that M is parallel to N. The symbols that sometimes we will use to refer to that, I like to use this notation. This tells me that both lines are parallel to each other. I can also mark down that angle 3 is congruent to angle 6 as well. And that's me labeling that information right there, highlighting it. But we use arc marks typically when we want to show that angles are actually congruent like that. Now, we're trying to prove that 1 is congruent to 6, right? So we're told, and we know from the diagram, that x is the transversal. And we also know that angle 3 corresponds with angle 1. And that is because they are in the same position with their group, right? Both belong to the transversal x. They both are in the upper left quadrant of their group from lines N and M respectively. So they're corresponding angles. And as a result, we know that angles 3 and 6 are congruent as well. That was a given fact, right? So we're kind of establishing a lot of given information here. So this is actually because of a postulate, believe it or not. The reason why they're congruent is because of the corresponding angle postulate. That would be the name of the reason. So we're stating that x is really just a transversal. So this is kind of by construction. So they just kind of drew that there, connecting them. And then this information here is given to us. We're also provided that information. And recall that, again, that information was provided to us. And so if we see that 3 is congruent to 6, and we know that angle 1 is congruent to 3, right, because of the corresponding angles being congruent, then we know that 1 and 6 can also be mentioned as being congruent as well, okay? And so this is more or less like a hand-waving proof, but a general idea is that two things congruent to the same thing are congruent to each other. That would end that particular proof right there. Right? So we've illustrated why is 1 congruent to 6. Well, because both of those angles end up being congruent to 3. Okay. So let's go ahead and identify, firstly, the relationship between the angles of 13 and 3 here, right? And the first thing you want to do is you want to identify the line or the transversal that both of these angles lie on. You can see that this line right here contains both the 13 and the 3. The vertices or the vertex of each angle is on that line. That is the transversal. That means you are comparing this group right here to this group right here. And that means when you look at 13 and 3, they are on the outside of the two parallel lines, the lines that would be here and here. So they're outside in the exterior area, and they're diagonally across from each other. So that tells us what the type of angle pair is. They're alternate exteriors. So by the alternate exterior angle theorem, they're going to be congruent to each other, right? So we want to reference the name. It's in the name of the theorem. It's alternate exterior angles. So 13 and 3, those are going to be our angles that are alternate to each other. And then, of course, you have the parallel lines, right? Now, the parallel lines in purple are those two lines right there. Okay, so that's what we want to relate first, is that transversal. Okay, so now we're going to go ahead and take a look at this example here. And what we're going to do is, here are two parallel lines and a transversal. And what we want to do is identify the angle that makes that angle relationship work, right? So we want to know what angle would I have to use to make a same side interior angle with angle 5. Angle 5 is right here. So what angle would make it a same side interior angle? Well, in this case, that would end up being angle 2, right? Because those would form same side interior angles right there. So angle 2 is the angle I need to make a same side interior angle with 5. But what if I wanted to use an alternate interior angle instead with angle 5? So how would I end up doing that? Well, For alternate interior now, we're looking across the transversal, but it's still on the inside, right? So the inside is in between the parallel lines, but it has to be diagonally across. So now we're looking at angle 4 rather than angle 2. And then lastly, the corresponding angle pair with angle 5. So we're looking at angle 5 again, and we want to see which angle on the other group, right? Now the other group is this entire group over here, okay? Which of those angles corresponds to angle 5? 5 is in the upper left kind of position, and so that means angle 1 is going to be our corresponding angle that we need here, okay? So angle 1 is the corresponding angle. Okay, so looking at this last example, we're going to use our angle relationships to determine the value of x. I noticed that we have our transversal t, and notice the blue markings on each line. That indicates that they are parallel. We need to have that relationship to set up these relationships ourselves, these equations ourselves. So we recognize that that is going to be an alternate interior angle pair. Okay, alternate interior angle pair right there. So because that's an alternate interior angle pair, I can take 3x and set it equal to 60. And then I can go ahead and divide by 3. So that tells me that x is going to equal 20. So I'm using that congruence relationship between alternate interior angle pairs to solve for x. And then if I go ahead and highlight this here in purple, 60 happens to be alternate exterior with 5y plus 10. If you look at these two parallel lines right here, both of the lines happen to be belonging to or cut by the transversal t such that the two angles 60 and 5y plus 10 are on the outside of those two parallel lines. They also happen to be diagonally across from each other. So that tells me that we have an alternate exterior angle pair. So what we can do is we'll take our angle value of 5y plus 10 and set that equal to 60. And then we'll subtract 10 on both sides. So we have 5y equal to 50. And then we'll divide by 5. And we'll get our value for y, right? So y is going to equal 10. So there's the value of y. We have our value of x, and we have everything we need from that. Okay, so your exit ticket, you are to identify or look at which angles form same side interior angles with angle 5. Okay, so a great example that I would refer you back to that we just did was this example right here. I would certainly look back at that example to assist you with your problem there. Which theorem or postulate justifies the statement angle 6 is congruent to angle 12? Okay, that's very similar to this example right here. What you need to think about with angles 6 and 12 on your problem is what type of angle relationship do those two angles have? What transversal do they both belong to? That can help you determine what type of angle relationship they have. And then lastly, I would also ask as a final tip for the final question, which theorem or postulate justifies the statement? Only one of the four possibilities that we've discussed allows for supplementary angles, right? So that means supplementary. Which of those angles, or angle theorems rather, references angles being supplementary? That's going to be my tip for your final question on your exit ticket for 5.01, and that is the lesson.